Welcome back. So, to review, we are working on building an Electron-based game engine that's going to be used to basically reproduce the Minicraft game. Minicraft is a game that it was written in, I think, about 24 hours, 24 to 48 hours, as part of a Ludum Dare competition, and has been reproduced so many times. It's kind of a neat game. It's like a 2D version of Minecraft. But want to reproduce that and use that game as the basis for building a little JavaScript game engine, and then from there, once that whole game is done and working, going to use that as the basis for building something more original. But last time we got the palette up on the screen. It's two. Oh great! I forgot the number of colors again. What is 6 times 6 times 6? 216. It's 216 color palette, which reduces the whole multi-million color palette available to our monitor to like 6 degrees of red, 6 degrees of green, and 6 degrees of blue. Makes the whole thing more manageable. And this is all the colors in the palette. So we're going to impose that restriction on us. If you dig around in the Minicraft code, you'll see things like this, where it's like the color for a chest, and you'll see a list of 4 colors. -1 means transparent, and then you'll see things like this. These are not palette indices. This is like the red, green, and blue. There's 3 digits for the red, green, and blue channels. And then that gets converted into a palette index, and then that is used to produce the color on the screen. Today, we are going to talk about the tile set. So, tiles. We were looking at that a little bit in the very first episode. Or was it the second? It was pretty early on. We won't need this ball rendering code anymore. So, let's go ahead and take that out. The 160 and 120, that's the width and height of our virtual screen. Yeah, I said I was going to talk about the input collection today. Mouse and keyboard input. We will get to that soon. We're not going to be able to get away with not doing that. Here, let's change this. I want to keep the background color, but we'll pull it from the palette instead of just generating the color. And we don't need to draw the palette anymore. Keep the update loop, but we don't need to update the sprites. I'm going to keep the ball class in case we care about it later, but I'm getting it out of the main file. Alright. And now we have something like a clean slate for working on our tile set. Great. Change that to zeros. That should be a kind of dark blue. I want it darker. Cool. Alright, so we have the image here. And let's start by throwing that image up on the screen. Alright. So we can get a pixel out of our image. We have a basically the image. There's a. I'm going to go back to the beginning. If we go back to the server side, the Node.js process, we have a little API set up so that if the renderer process signals the backend with the gfx get tiles call, then it's going to go through our API gfx, and there's get tiles. It uses the image.js library to load in a PNG file and pass back the number of components, like red, green, blue, alpha, the pixel data, and the width and height of the image. We can't return the object direct. We could, but most of the data is thrown away because it all gets serialized as JSON, so the whole class loses its identity. But we pass that to the renderer process, where we then, there's the get tiles, and that's processed through our own image class, which basically allows us, it gives us a helper function to pull pixels out. And it returns the red, green, and blue channels for that. So if we wanted to render that image to the screen, think the screen is our screen resolution is actually smaller than our image, so we won't be able to render the whole tile set. What we do is like this. And I'm trying to remember exactly how you do this in JavaScript. I think I can do that because it returns red, green, an RGB, basically anonymous type. And I think doing this should break it back down into RGB variables. And then we can do a set pixel, X, Y, and then like that. See if that works. There you go. There is most of our tile set, the bits that fit on the screen. But one of the tricks here is we have to be able to then, well, we got to break those up into tiles for one from the full image, but we also got to be able to recolor those. And the recoloring process, let's go ahead and look at that, because that's kind of an interesting thing. Oh, where did I put our palette class? I think, yeah, it's still there. I want to shove that into another file so I don't lose it again. I don't think I need to export the class because I am exporting the actual palette. And actually, I don't even need a class for this because we're only ever creating one of these. So, you know what? I'm going to leave that. It doesn't hurt anything. You can see that in the Java code, there's a color.get. You pass it 4 numbers, and it gives you basically a really big integer. Let's load in that color class. In Java, you can have 2 functions with the same name but different parameters. You cannot do that in JavaScript. But also, I don't really like shoving that all into one big integer. The problem is when you go back to draw it, now you can see that there's it's doing a lot of math. And we shouldn't have to do all that math. We should just be able to have a little array of colors that we pull out the color we want. So I think I'm going to do this a little bit differently and just have it return an array instead of adding them all together. We should know in a couple episodes if I deeply regret this decision. Like that. Okay, where were we? Setting pixels. Pulling out the RGB values. And I forgot to import the palette. So of course it's broken. There you go. Maybe. Oh, what I forget. Color is not defined in the palette. Okay. And there. File not found. I still might end up converting this to TypeScript, I don't know. Some of the syntax is a little easier on the eyes when you're using TypeScript. Alright, so it's all black and white that the tiles we care about, but it's 4 specific colors. And basically we need to pick any channel, red, green, blue. They're all going to be set to the same value. It's grayscale. You divide it by 4, and then that will give you an integer to index. It's basically an index into that array. Like this. Pick a channel, divide it by 4, floor it to make sure you get an integer. And let's see if we can find the grass tile. Oh, grass, where are you? Tile, grass. No, that's not a good example. Well, the grass color changes depending on what level you're on. Just a neat trick, but not helpful for us right here. Oh, default grass color 141. Perfect. But then the rest of it Alright, so that's the array we're going to use for our grass. But we're going to recolor the whole image to use that. So this is how we'll do it. Let me think. use that function call for 1. And it's actually returning the colors. I need to remember the get, and then that returns that array. Let's comment this a little bit. There we go. That should help a little bit. See, now the IntelliSense knows that this variable is an array of colors. Oh, actually we don't need an if block. We can do it like this. Ta-da! But does it work? What I forget. Cannot read properties of undefined. Set pixel reading R. Interesting. I wonder what it's actually retrieving here. So that looks right. V should not be 20. Oh, actually dividing by 4 is not enough. Okay. Because it's like, here's the problem. If R equals 255 and V equals R divided by 4, then, well, V is, it rounds to 64, which is not in the range of 0 to 3. So what you have to do, actually, is R divided by 64. Or like, after flooring that. Like that. I was dividing by the wrong number. That should actually give us the right value. It looks kind of funny, but it is all green colored now. I feel like I forgot something. Oh, I did forget something. Oh, did I? There's the original line from the Java program. Well, maybe I didn't. Let's... check something. Here's a screenshot from the Minicraft game that we're reproducing. And you can see the little grass tiles right there. It looks like we got the colors inverted, which is kind of funny. Wonder how that happened. Oh, it probably has something to do with the math that I told you I might regret cutting out earlier. I bet if we reverse the array, that it'll give us what we were expecting. Yeah, okay. Here's what we're going to do. In order to maintain backward compatibility, what I'm going to do is just reverse this. So I don't have to change it every place else in the code. Ta-da! Let's grab another one to test with. So we have all these tile types. Items. Let's see, there's a workbench somewhere in here. So the workbench has those 4 colors. The complication here is that the negative one is supposed to be transparent. Let's just run it and see if it breaks. Didn't break, but if you look, there's the workbench right there, and it is the right color. I colored everything with the workbench palette, which is kind of funny. I want to be able to see the blue behind that. So what is it returning for the negative one? Need to know what it is so we can filter it out. It's just returning a 255 instead of a color object. That's kind of interesting. I'm not sure why it would be doing that. Oh, because of that. That was actually an error. Now it's undefined, which actually is more appropriate, despite the error. The way we properly fix it is like that. Only set the pixel if the color exists at that index. There you go. Now you can see the background through the transparent part of the tile. You can see the background poking out around the little player tile that you can almost see at the bottom there. And we're going to pause there today. We now know how we're going to recolor the tiles. And yeah, we'll pick this up soon. See you later.